Okay, we are live. Hello, everyone. Welcome to the EVO seminar series. Our guest today is Jeremy Sherman, who has written a new book, which actually I should have brought it with me. It's at my bed at home. He's written a book called Neither Ghost Nor Machine. Does Jeremy have a copy? You want to go get one?
I have
Yeah.
24, but they're still in the box. Let me get it out.
Okay. So he's written this book called Neither Ghost Nor Machine about, let's say, the origins of value. About an important and frequently overlooked question in the biological sciences. And as soon as he returns with a book to hold up to the screen, we will give him the microphone and begin the lecture.
Here
Maximus.
we go. Here we go.
Yes, Mel.
And now we can hear you,
Can
Mel.
you see? Oh, we can hear me now? Oh, that's good. Excellent.
Now,
Testing.
introduce yourself,
Hi,
Mel.
everyone. Hi, I'm Mel. I'm helping Maximus to facilitate this course this semester. I'm fascinated by minds and how they evolved.
Fabulous. All right. So, and here's the book, by the way. Can you see it? The subtitle's important. Maximus said the emergence of value. Yes. Among a bunch of other things that we can't help but talk about in the world of the living. So it's about the emergence of selves, value. Trying ends up being one of the more important concepts. That is, some things try and other things don't, and we have to explain that. Yes, and this is based on 21 years collaborating with Terence Deacon. I was getting a PhD. I thought. This was late in life. I was like 40 at the time. I had done a lot of social science. I did a master's in public policy at Berkeley. I was basically an environmental activist for decades. And then I had a juicy midlife crisis, got interested in evolutionary theory, started to study evolutionary psychology, found its limitations, and then found Terence Deacon, who was then a neuroscientist at Harvard, working on the origins of human language, which for him entailed a fair amount of transplanting pig neurons into human brains. Controversial work, but he was...
Wasn't it the other way around? Wasn't it human neurons into pig brains?
You know, anyway. It could have been. They were, yes, but these chimera, he was definitely in the chimera game because he was trying to understand plasticity and how language formed. But he was just turning his attention. He had just finished writing a book called The Symbolic Species, which when I read it back then, I cried. I actually cried, not because it was so moving, but because I was so inept. It was over my head. It made me sad. I had a rule back when I was in school that if a class didn't make me cry at least once, it wasn't really a good enough class. I needed to be whipped somewhere along the way, and then by the end of it, I needed to feel like, oh, well, why didn't you just tell me? That's kind of the story of my life. I've wasted my whole life learning things I now already know. And so I was definitely doing that back then. And then I ended up meeting Terry at a conference, and I just decided to get this PhD, and I invited him onto the committee, and we had great compatibility on most fronts. And we have been collaborating for 21 years since, while he has been working on the topic of this presentation. He got interested in, basically, you could say, in how mattering emerged from matter. So mattering would include everything that's implied, but kind of danced around in evolution, in biology. Biology can't get very far if it doesn't talk about adaptations. Well, what are adaptations? You can say they're functional fittedness. I'm going to use fittedness instead of fitness to keep it from all the confusing possible implications. By functional, I mean good for or bad for, useful. So you're already into value, as Maximus said, when you're talking about function. And fittedness, what is that? It goes by various names. Terry and I have been talking about it this week and what name it should go by. But it comes down to function in a circumstance, in a likely possible future circumstance. So he's been calling it representation. I'll explain why in a minute. I'm not comfortable with that term. I'm going to call it interpretation. So you can't really, I will argue, do biology without implying at least value, that is usefulness. Hard to talk about an adaptation without talking about it being useful, and then you got a question about useful for whom. There is no such thing as usefulness if there aren't selves on the scene. You got to have it be useful for a self, real or imagined. You know, for a long time in intellectual history, we thought everything was useful to a self called God. So here we're talking about science. I think of science as the pursuit of natural explanations for all natural phenomena. So you can't just pull out a God to explain anything in science, or else science goes haywire. You could explain everything by saying, well, God did it. So we're not doing that in science. We're looking for natural explanations. So good for or useful for someone becomes a real question if you're not going to employ the God explanation for things. So that's what we're going to be talking about today. And I'm going to jump into a slapdash PowerPoint that I made yesterday and tried to fix today. Let's see what I've got here. Let's see, I'm now sharing my screen, am I right? You see my screen? Okay. Now, interesting, because it makes it, let's see, hold on a second, let me see if I can pull this off. There we go. Okay, here we go. All right. And now I have to go into view. Anybody know where you go to get presenter view? Maybe this will do it. That's okay. Here I am showing the.
Go back to the menu. Sorry.
Let's see. Well, you end up. Let's see. Does anybody know how you get into the actual slideshow? I have just have.
Can you hear
this
me?
Shows you how frequently I end up using this program these days.
Can anyone hear me?
Anybody know how you get into
yeah, sorry, I was on mute. I was talking the whole time. So you were at the right. You're on the right track. You just want to go to View Slideshow.
Oh, slideshow. There we go. There we go. Here we go. All right. So the big lacuna, kind of a pun on big kahuna for no reason. I have a mind that tends to pun more than is good for me. Science and philosophy's biggest gap. And the question I'm posing today is, what would happen if we filled it? An image came to me this morning of crowds on either side of a big chasm, pressing against the edges, against the cliff, kind of crowded in there, kind of shouting at each other. That's an image for how the gap kind of feels to me these days. So I'm going to just lay it out straight up. So I got these mystery things that have mystery properties, yielding mystery behaviors that I'll evolve via, which have yet to be explained in relation to. So everything in these first four columns, I am arguing, are not yet connected to everything in this far right column. That is, everything over here is the stuff we use to explain things that matter, means to ends behavior. And then over here we got all the stuff that we've developed to explain cause and effect behavior. And I'm saying there's a huge gap right here. So look at it. You can talk about the mystery things. These are nouns. Okay, so organisms, individuals, selves. One of the things I'm doing we're doing as part of this project is expanding the definition of selves. Our language is not even conducive to looking at this gap. And it'll show up, for example, I'll show you how in a little bit. But anyway, what you got is, I'm going to say that a tree is a self, a bacterium is a self. And I've got to boldly defend how you'd ever get selves out of physics and chemistry. So selves, subjects, living beings, creatures, agents, sentient beings, spirit, soul, etc. Now I'm draw attention to this. In science, we think it's kind of sketchy to go with spirit or soul as explaining what goes on in us. But I'm going to argue that no matter what you name it, even if you call it something more technical sounding like agents, you still haven't explained anything. Naming is not explaining. I got all of these behaviors over here. I see them and I come up with, I have to have some reason, I have to posit something that is the distinctive feature of living things that make it so they can do all this stuff. So I simply posit something. So you get this across the social and life sciences. You've got individuals or organisms. Do we know what an organism is? I'm arguing we don't yet. Do we know what an agent is? No. Well, an agent is something that's got agency. Do we know what agency is? Has anybody ever seen agency? No. We've seen what happens as a result of agency. If something's got agency, it does trying or striving or aiming or reproducing or making effort or working to survive or acting, all of these different things. And the life sciences and social sciences do just fine on the assumption that there must be some distinctive feature here, but we've never explained this feature. What is it that makes something a self instead of a non-self? I can't say, well, a self tries and think that I've explained anything. And that I think I've explained selves. I may be able to explain trying. I had a nice conversation the other day with Vivian Ming. Vivian Ming is a very big name in neuroscience these days. She's one of the experts on brain to machine interfaces. She's coming up with ways to make us more happy, more productive. She's coming up with ways to increase our working memory. And so she's a darling of Silicon Valley. She mentioned the other day that she was just invited to be the chief scientist for Amazon and turned it down because she didn't want to work with Jeff Bezos. She's a really interesting character. She was a he. She's transgender. And I saw a presentation by her in which she laid out her theory and wooed and wowed the crowd. They were amazed by her story, including her rise like a phoenix. She had almost committed suicide before the sex change and is much happier now. And they were very moved by the story. And after she gave her lecture, people gave her a standing ovation. I happened to get to ask the first question I asked, is the brain a machine? And she said, well, all we ever find in it is pushes and pulls, mechanism. So unless something is added, yes, the brain is a machine, which means that she's really working on machine-to-machine interfaces. And no one in the crowd seemed to get it, that they were wowed by a person who was having all of these emotional experiences in her striving to find her way in the world. And machines don't do that. Machines don't wish for sex changes. So we got together for lunch after that and had a great conversation in which she made very clear that she's a life and social scientist. That means that she can take organism or selves as a given. She can talk about the things that they do, and she can just try and find correlations from this side to this side. I'm going to bet that that's most of what you've been doing in biology. It's kind of the assumed approach. But I'm also going to say that none of the things on this side have been explained. You've got an argument here that some people think bridges, which is you get all of this stuff once you have evolution. So we'll visit that one in a second too. Okay, so you see this basic scheme I'm playing out, and I should have made this line larger. Speaking to Mel's interest, the fascination with minds, I'm going to argue that mind is another thing. Did I put it on this list? It belongs on here of things. Mind would be another one. A whole lot of philosophers and scientists and cognitive scientists especially aren't really interested in this gap right here. They're interested in the human gap, what you get once you have conscience, once you have consciousness and qualia. As if we've already figured out all of this stuff in the evolutionary world, in biology, because it's all explained by evolution. I'm saying, no, it's not. We don't even have a great explanation for evolution. Why? Because though we know how evolution works, we don't know how it starts. Why? Because evolution doesn't generate all of this stuff. It hones all of this stuff. But you got to actually have all of this stuff, or at least most of this stuff, before evolution starts. That these three columns over here are a precursor to natural selection. I'll come back to that argument in a minute. Okay, so you've probably seen this cartoon. It just hit me this week how relevant it is to our work. You got all of these cause and effect equations over here, all the stuff in physics and chemistry. And then you got all these means to ends equations over here that you get out of the life and social sciences. And I'm saying there's a gap right here. And when I met Terry, he was basically saying, I think we should be more explicit. Oh, now look what I've done here. Just a second here. I can do this. It's funny. Wow. Sorry, guys. Oh, man. Okay. All right, I can pull this off here. Hold a second. Technical incompetence. Here we go. I think we should be more explicit here in step 2. That's what we're saying. That between the cause and effect equations and the means to ends equations, we don't have bridging equations. We may think we do. I read all of these books by the cognitive scientists, Dan Dennett, Rob Sapolsky, all these guys, and they act as though it's basically been filled out. That all you need to do is to say, well, this chemical causes this means to ends behavior. But I'm saying, no, you can't just say that a chemical causes a behavior, because a chemical doesn't have behavior. It's a phenomenon. Chemistry is cause and effect. Behaviors are means to ends. How do you bridge the gap? That's what we're talking about here. And so, like I said, all these guys are basically dancing around a hole in our understanding. I picked up this quote from a book by Jessica Ristkin. She's a historian of science. She wrote a wonderful book called The Restless Clock. And she's quoting a biology student here, and I don't know if this resonates for you, and I'd like to hear. The biology students are saying certain verbs are worse than others in our field. Those that seem anthropomorphizing, such as want, are only permissible in casual settings. Biologists can say and allow their doctoral students to say that cells want to move towards the wound in conversation, but never in print. In contrast, other active verbs do not seem anthropomorphizing. Proteins control chemical reactions. Muscle cells harvest energy. Genes dictate the production of enzymes. So that's what I was just talking about a minute ago. You got chemistry that is doing things that would be hard. I think it's inescapable to say that control is a means to ends word. Harvest is a means to ends word. Dictate is the means to ends word. So the burden is on us to explain how you'd ever get that move from chemistry to these moves, which are biological moves. You can do lots of biology. You can do pretty much all of it, just assuming the magical miracle happened. But you cannot explain life. So you're right up against the edge of life if you haven't explained how control could ever come out of proteins, that sort of thing. By the way, is that your sense of it? Do any of you know from your biology education anything like what this person is talking about? This business about how you got to watch out for anthropomorphizing. Anybody?
Very much so, yes.
Anybody? I just want to make sure I'm being heard. Can you hear me even?
Yeah, there's a bit of a lag.
Can people hear me?
Yes.
Yes.
Oh, good. Great.
Well, for me, I haven't really experienced the need to be very specific on what verbs I use in biology, more so in biological and technological courses I'm taking.
I'm having trouble hearing. Can someone paraphrase? Who's got a better mic, or can you say it again?
I fixed the problem. Nwang, if you could just repeat yourself.
Okay. Well, personally, I haven't had issues with needing to be cautious about what verbs I use in biology, more so in the bioanthro courses I've taken, where word choices play a bigger role in the papers that I would write.
And was the choice of words at all governed by something like the kind of norms we're talking about here?
Yeah, I think because there is a casual setting for certain words, like the want example. Like I would say that if I was just talking to a professor, but if I was writing a research paper, then it could easily be argued that like that a cell can't want anything because it doesn't have a mind of its own, say.
Right. Yeah, that's what I'm talking about. And yeah, it would probably show up. more in certain biological circumstances than others. If you're just talking the biochemistry and never crossing over into functionality, it'll show up less. I've talked to biology students who said pretty much the same thing that this one is saying. Anyway, whether it's a problem or not is up to you. And by the way, I would welcome anybody to jump in any time here with objections, critique, wait a minute, whatever, questions to make sure I'm being clear. But that's what I'm gonna posit, that there have to be certain taboos if you're not going to dig into this hole.
Well,
and yeah, go ahead.
Sorry. So I'm more in the philosophy of biology and philosophy of mind, working with people such as Daniel Dennett, who's really likes to play devil's advocate in this sense. He really wants to push the quote unquote design stance, the intentional stance when it comes to replicators and such things, taking after Dawkins, and really decries anthropomorphization when it comes to attributing or over-attributing mentality to more primitive organisms. So I run up against this a lot.
Yeah, that makes sense. Yeah, because he's what we would call an eliminativist. He actually wants to say, I mean, I would paraphrase him as saying, you may try to want to think that you have trying and wanting, but you don't, which to me is incoherent. He's a big fan of Terry's work, and there was a time last year when he said, you know, Terry changed my mind. And then he came out with his most recent book, From Bacteria to Bach and Back. And yeah, he talks about Deacon's work by saying that there's a Cartesian wound. Remember that Descartes thought that there were two things. There's res cogitans, the thinking thing, and there's res extensa, which is the thing that's extended in the material world. In other words, the physical chemical. So this is your mind-body split. And he talks about the wound, but he answers it by saying, no, really, there is no thinking thing. That all you are is a bunch of pushes and pulls that evolved, and evolution is like unintelligent design. And that if we only understood that, we would get over ourselves as living beings. I also should be clear that it's not just anthropomorphizing, there's certainly that, but notice what goes on there, the assumption that wants emerge with human life, not earlier. Trying emerges with human life. And so you get this whole flavor in cognitive science where, yeah, we're with Descartes. Animals are just machines, but humans with their consciousness and their qualia, their feeling of this or that, the feeling of green, the feeling of blue, the feeling of sadness, that's what has to be explained. Everything else is already explained. We're saying, no, it's not explained. It's not just a question of avoiding anthropomorphizing. Every organism tries. Every organism wants, even if it doesn't have feelings or consciousness. That I look at the tree outside, it apparently is working to try to keep itself going. I got to explain that kind of work. It's a particular kind of work. There's all sorts of work in the universe. You know, molecules are working on each other all the time. Through Brownian motion, they bump into each other. They do a job on each other, you could say. But none of that is wanting. Wanting is a particular kind of work which is closer to trying. Or you could say you try to get what you want. We haven't explained that. We're dancing all around it is what I'm saying here.
There's
So here's one fudge that's as much symptomatic of what I'm talking about as anything. Teleonomy was the biologist's compromise that enabled them to talk about wants without talking about wants. It means a kind of a law-like appearance of telos, end-directedness, purpose, the false appearance of purpose. So basically they're saying, sure, it looks like it's trying, but it's just whatever survived evolution. I like this quote from David Hull, who's a philosophy of scientist. He's yeah, that's what I guess that's what you call him, philosophy of scientist, philosophy of science professor. He says Haldane can be remarked. So Haldane's, of course, a famous biologist, you know, but that can be found remarking teleology, which is real purpose, is like the mistress to a biologist. He cannot live without her, but he's unwilling to be seen with her in public. Today, the mistress has become a lawfully wedded wife. Biologists no longer feel obligated to apologize for their use of teleological language. They flaunt it. The only concession which they make to its disreputable past is to rename it teleonomy. Does that make sense? You see what I'm saying there? You hear me? Does everybody hear me?
So humans are muted, so there's a little bit of a gap between when you.
No problem at all. I just want to make sure I'm not talking to a computer screen. Okay.
Yeah.
Are you?
Well, I think this is a good place to stop and see how we're doing. Mel wants to speak. What's up, Mel?
Oh, I was just clarifying that you have the power to mute and unmute me.
Yeah.
Do you want to leave me unmuted and then I can unmute myself?
So the problem is you have a lot of background noise, particularly.
Yes. So I'm gonna keep myself muted and then unmute myself to talk, if that's okay. Cool.
Well, I'm wondering if we could hear from some of the other folks in the class. Maybe Victoria, could you? What do you think is going on here? Like what is the problem that's trying to be addressed?
Well, to be quite honest, I'm a little confused by the teleonomy concept. Yeah, I'm not really understanding this slide in particular. I understood the first slide and agree with it, but I'm not really sure what's exactly being said with this new concept that we just went over.
Good. I'm gonna pull down an example that you get from Wikipedia on it.
Okay.
Okay, so it was illustrated here. You can see it in Ernest Mayr. You probably know that name from biology. He was a big neo-Darwinist in the mid last century. A wood thrush migrates in the fall in order to escape the inclemency of weather and food shortages in the northern climates. That crosses the line for me, saying, no, that sounds like you're talking about it actually having an intention, that the wood thrush intends to escape. He's happier with teleonomy's approach, would be to say that the wood thrush migrates in the fall and thereby escapes the inclemency of the weather and the food shortages of the northern climates. Now, to me, and thereby escapes makes it sound like cause and effect. This relates to something. What's it called? It just jumped out of my head. It'll come back to me. But it's basically, look, evolution explains it all. You're passive, but the only reason you give the appearance of actually wanting to do anything, actually being active on your own behalf, is because you happen to have lived. Mm-hmm. So if you live, we can try to explain why. We can say, well, you live because you escaped the inclemency of the weather and the food shortages of the northern climate. So that's why you lived, but your living is still passive. So it's a kind of, to me, it's like a legalistic loophole that they're trying to dive through so they don't have to face the fact that actually organisms are agents. Jessica Riskin's book, which I mentioned a minute ago, is all about the history of our attraction and aversion to agency concepts. That was played out in the 17 and 1800s through all of these efforts to make machines that act like humans. It's exactly what we're seeing in AI and all of this. If it acts like a human and looks like a human, then it's a human. It's meaning that a machine is a human. So our machines becoming like us becomes a question. Are we like machines? That becomes a question. That you would get in a time like this when the technology is getting better and better at imitating humans. And if it turns out that a machine, just a bunch of cause and effect mechanism, gives you everything you'd get from a human being, then agency is bunk. There's no such thing as agency because machines obviously don't have agency. And you end up with positions like Vivian Wang's, which is, the brain is just a machine. And then I asked her in a conversation, okay, And you'd say the same about hearts. Yeah, of course, about all the body. The whole body's a machine. She works on machine-to-machine interface. So there's, I don't know if that explained a little bit more what the business is about teleonomy. Did it?
Yes, it did.
Right.
But I wouldn't say I agree that humans are the only organisms that want.
Me neither.
I think the only thing that separates us is language, and we can portray our wants and desires by, you know, speaking. But if we couldn't talk about it, I don't know how other, you know, humans would know that we wanted or anything, you know. So I think that we can't just say only humans want.
I'm completely with you on that. That's kind of the central point here, which is you may think that all you got to do is figure out how human minds work, but it's much deeper problem than that. And I want to go back to what some would be willing to call minimal mind. That minimal mind is anything that's trying to keep itself going has minimal mind. It's not cognitive, it's not emotional, but there's no escaping teleology, end-directed talk once you get into life. I can escape it quite handily when talking about my table. It's not actually trying to do anything. It's functional, but it's functional for me because I'm trying to do things. And the same would be true for all organisms. So I'm right with you on that. We're on the same page there. Okay, good. So here we go. Teleonomy. Here's one of the fudges. I just mentioned it before. Evolution by natural selection starts and explains all of life. I'm kind of floored by this one. It's an amazing feature of what's going on in biology, which is how does life, evolution explains life. It explains all of life. We don't really need anything more. Evolution was the ultimate vindication for the kind of approach that Dan Dennett takes, which is to say, look, you got stuff. Some stuff lasts longer than other stuff. That's natural selection. That's differential survival. Once you got that, you've got life. So it's almost as though biologists think there are all these natural laws of physics and chemistry, and then midway through the universe's history, sometime like last July by the calendar I mentioned the other day, where you try to compress the life into a year. Actually, it's maybe more like August or September. You collapse the universe history into 1 year, and it'd be 2/3 of the way through. The universe is roughly 14 billion years old. Life is roughly 4 billion years old, so maybe 2/3 of the way through. Suddenly, this new law comes in, natural selection, and that explains life. Well, natural laws don't work like that. They're kind of timeless, at least in our universe. A guy named Smolin argues that natural laws might have variability across universes. So I'm going to say that claiming that evolution explains life is like saying that erosion explains mountains. Yeah, it explains how they're sculpted or honed, though both of those words imply trying. I don't think evolution is trying to do anything. Natural selection is just that some things fail to keep trying. So yeah, it explains what's honed. It explains honing, but it doesn't explain what's honed. Just like erosion explains what's the honing, but not what's honed. It doesn't explain mountains unless you've got something that can be eroded. And
I think.
Go ahead.
Sorry.
No,
I think critically that explanation of what an organism is and what agency is and what trying is completely absent from the replicator selection piece. And so for me, I've been recently bumping up against cultural evolutionary models, and even people like Steve Pinker, who are just total gung-ho neo-Darwinists, adaptationists, will say, no, wait, cultural evolution cannot be explained as replicator selection because you're totally ignoring agency. And for me, my perspective is, yeah, but how did agents get here? I mean, natural selection doesn't explain agency. You've got organisms that are able to act and of their own volition, and replicator selection has never taken interest with that question.
That's right, and that's become a hot topic for him and his wife Rebecca Goldstein, who've just gotten interested in mattering. But if you read what they say, they want to talk about mattering, but they also want to stick with the replicator model. So the replicator model, so you got various versions of universal Darwinism. One says, look, whenever you've got anything that has a differential endurance, you've got evolution. And others will say, no, as long as you got replicators. So what is a replicator? It's anything that is copied. Well, molecules are copied all the time. You know, the biggest idea in origins of life research is RNA world, which is once you've got RNA molecules copying, you've got life. That's a replicator model. Well, how do these things copy? I'm going to say they copy passively. The molecules aren't trying to do anything. It's just that under certain conditions, they'll copy. That's just catalysis. That ain't life. That ain't life, because all the business end of it is external. It's what happens to them in certain environments. They're passive. That ain't agency. And so at least we make a distinction between replication, which is passive, and reproduction, which involves some hustle on behalf of the self itself. That is, the kind of agency starts once there is what I'll call self-directed work by a self for itself about its environment. And you miss all of that if you're talking about replication theory. You don't need to do any of that. You can just say, look, when molecules start copying, some copy longer than others. I can stand outside of two chemical chain reactions and look at them. I can root for one or the other. I can say which one won and which one lost. But that's all in the eye of the beholder. The molecules in that chain reaction are not trying to do anything. It's just about their situation. The circumstances are doing all the work. There's no agency in it. So I'm saying one of the fudges is to claim that evolution explains it. And I am floored, just floored by how often this comes up. Floored because obviously, though evolutionary theory is very well grounded, there's huge consensus about it. We're working out the finite details of it. We still don't have an explanation for the origins of life. So and we know that the origins of life is a question. Well, if evolution is that developed, why don't we have an explanation? It should fall right out of it. Well, it doesn't if you don't focus on this big question. Basically, what is trying and how did it start? Here's another source of the kind of equivocation you get. You get these words that you can use interchangeably two different ways. One is as though they're functionless, and the other as if they're functional. Mechanism is a great example. Quantum mechanics is functionless mechanics. Mechanism is starting to bleed over towards functional. You know, I can say he has a mechanism for achieving this. And then machine gets all the way over on the side of functional, because we know that machines are functional. They're not functioning on their own behalf. They're not doing anything to self-reproduce or the other things that we insist that agency entails. So you get these philosophers who are and scientists who are dancing on either side of it, using the term as functionless when they want, using the term as functional when they want. They're talking out both sides of their mouths. That's what equivocation is. Here's another example, code or template. I would even put the word representation on this list. An imprint left by a rock when you take it out of the ground is a code or a template or a representation of the rock, but it's functionless. But then we talk about the genetic code, and we're talking about a functional code. So which is it? How do you make this transition? That's not a question that you can, that's a question you can stump a whole lot of scientists with, which is what's the difference between a one-for-one mapping that is totally functionless, like that imprint left by the rock, and the kind of functional stuff we're talking about when we talk about template molecules, DNA and RNA, or codes. Another one is information. I'm guessing you know something about Shannon's information theory. Do you know this one at all? You know its consequences because we all live with them. Bits and bytes are a product of his theory. Can
we hear from the student? Is everyone familiar with what Shannon information is?
I am not.
Good. Let's walk through it quickly. I'll give you a simple example. He does an interesting thing. He, in a way, it parallels what Darwin did. He's talking about what happens as a result of what doesn't happen. So if I've got a coin, It's got two sides, two possibilities, even possibilities of it falling heads or tails. He argues that information is the reduction in possibilities. So if you've got two possibilities and then it falls on one side or the other, you've reduced 2 to 1. That's one binary bit of information. So information is a reduction in possibility. Now that happens all the time in a functionalist universe. If a rock is about to fall and it could fall in 2 directions and it falls in 1 direction, he counts that as information. And he can measure it, which is very cool. Problem is that you can measure all sorts of stuff that is functionless. There's a great history of the concept of information by James Glick, who's a wonderful science writer. It's called Information, a History, a Theory, a Flood. And throughout the book, he's talking about information in Shannonian terms. The history is Shannon's development of the term. Just towards the end of it, he has made the case that the entire universe, everything in it, every quantum shift is information. Then his last chapters are about how we are now experiencing a flood of information. Well, what the hell? I mean, if it's all been information all along, how could we be experiencing a flood of it now? What's the difference between information, as Shannon described it, which is completely functionless? It's not information for something, for someone about something. It's just anytime you get a reduction in possibilities. He doesn't even notice the question. And in his book, he doesn't use information for or information about once. And yet there is no talking about information as we normally use it without implying something about information for, information about. Maximus said that this is kind of about the emergence of value. We talk about good and bad information. That's value. So there's no value in the Shannon version of it. And then, go ahead, yeah.
Sorry. So what Shannon was trying to do, Shannon and Weaver, actually, with this mathematical theory of communication, what they were trying to do was just fix telegraphs, basically. But what incidentally happened was they described a mathematical probabilistic relationship between states, and they made a kind of universal concept of information that was substrate neutral. So what that means is that you could convey pictures or audio or text or anything in this kind of universal language. And that is why we have computers today. Without that brilliant insight, we would never have been able to digitize anything. Exactly. And what that digitization revolution did for us was not only in getting us to computers and the internet and all of, most of the incredible technological and scientific advances we've had over the past century. What it did was it also gave us incredible insight into biology and mentality. So being able to say, before we had no clue how we got embryogenesis, how we got, I think I mentioned this last time, how we get this full complex organism out of a genetic code and some undifferentiated material, or how we get all of the complex behavior and experience of a mind out of this brain thing, which was built out of random material guided by this genetic code. And we're able to conceptualize of minds and of DNA in terms of, it's just code. It's just information encoded in the DNA. But it's not, right? Because it's not about, a computer isn't about something. And so this concept of semantic information is different from Shannon information in that it is about something. It represents something. I know we don't like that word, but
it represents something for someone, I would also argue. Right in there. It represents something for someone who is trying to do something. And by someone, I don't just mean humans, I mean all organisms. So what you're talking about here, in my book, I capture it with the term sacrificing viability for inviolability. You'll find this across the sciences. We would like to find inviolable laws of nature. We find a way to quantify something, and we latch onto that the way that they latched onto his communication theory. Shannon was ambivalent about this extension of his theory from basically trying to figure out how telephones work all the way out to explaining how all information works. But he did allow for some of it. Weaver did say, wait a minute, you know, we've done an interesting thing here. We have, basically he says we have sacrificed viability with this term, but you can see how we would just gravitate towards it because it gives us a kind of concreteness that scientists love, and understandably, because it makes it, you know, it makes possible to do controllable experiments. But the thing about it is that his measure of information, it's a little bit like miles. Yeah, you can measure roads in miles, but not just. You can measure anything in miles. So the fact that you can measure human information or living information in terms of bits and bytes does not actually mean that that's all, that you've explained the difference between the living and the non-living, because you can measure anything in information as he's defined it.
So I want to make a little bit more space for student input. Melvina, I'm wondering if you wanted to chime in and you know, what is your take on what's going on?
Your honest take, including skepticism.
Wait, hold on. Let me turn your volume up. All right.
I'm still just trying to gain understanding of the overall topics that he's talking about.
Can you talk a little louder? I'm having trouble hearing.
Oh, I'm just trying to gain understanding of like what you've been talking about so far. Like I haven't formed my own opinions yet.
Cool.
Yeah.
Do you have any questions?
No, I don't have any exact questions right now.
Okay.
Do you have any broad
Anybody else?
questions? Do you have any inexact questions?
Richard?
Maximus, can you
Yeah.
unmute me? Sorry. Do you have any inexact questions? Do you have any broader questions?
No.
Cool. Does anyone else?
All right, let's keep going.
Okay. Yeah, Terry talks about Terry Deacon, the guy who's basically come up with these questions. I don't think I would have necessarily asked them had I not met him. He's the guy who basically cornered me and corners us with these questions. He talks about this as a perfect storm, that if you look at the history of information theory and exactly what Mel has just described, this whole way in which we're thinking computationally about minds, as a perfect storm. We discovered DNA, we started to develop computer science, we were finding all of this power that Mel describes, and as a result, we are incredibly powerful these days. I mean, we wouldn't be having this class remotely if it weren't for all the power we've got from it. And in a way, it blinds us to this more elusive issue that's underneath it. So anybody who is feeling like, yeah, I'm still just trying to wrap my mind around it, that is the right response, it seems to me, which is we've been grooving along for a long time without noticing that the groove is actually a bit of a rut when it comes to these big questions, like how mattering emerges from matter. And so if I come in here and start saying, yeah, wait, there's a big question we're not dealing with here, there's usually going to be a lot of confusion. One of the things I usually get 4 responses in general conversation when I raise these questions. One is, Jeremy, it sounds like you got too much time on your hand. Another is, no, that will always be a mystery that we'll never solve. Another is, oh no, that was solved by evolutionary theory or this or that. And the fourth one is, that was solved last week in a Facebook post I saw where they said that quantum mechanics explains consciousness, something like that. And what delights me is that sometimes I'll be with someone who give me all 4 of those at once. It's just amazing to me. And that's yet the natural response. That's exactly what you do. You say, well, I got all these ideas about them. They're not coherent. One minute I'm saying that it can't be explained. The next minute I'm saying that Facebook explained it to me the other day. Doesn't matter. The fact is that your mind is kind of being snubbed. It's a bit of a cosmic wedgie to suddenly think, wait a second, we made all of this progress in the physical sciences, all of this progress in the life and social sciences. How come there's not a bridge? Now, another term that we use in equivocation is simply cause. I'm going to argue that cause and interpretation are radically different. And yet I don't think you'll see that in most of the literature you read. An illustration from the human world is that a stop sign causes you to stop only if you crash into it. That's not why we stop at them. We stop because we interpret them as about something for us. About traffic, about not getting a ticket, about not dying in cross traffic, that kind of thing. That's very different from cause. And yet we kind of gloss that across the life and social sciences. So after cornering ourselves with the right question, the way Deacon does it, he imagines an aimless universe, nothing in the universe trying to do anything. We imagine nothing but classical physics and chemistry. I mean, we could go out of the quantum level if we had to, but we don't think we've explored the classical physics and chemistry enough to know that you can't find the answer there. And not only that, life really, for the most part, is happening at the level of classical physics and chemistry. So you imagine an aimless universe, physics and chemistry, and chiefly this one big problem for life, which was first picked up by Schrodinger, the physicist. He says, here's the real problem for life, is that everything's falling apart. Everything's petering out. And life isn't, or else it still wouldn't be here 4 billion years after its origins. I mean, we're not existing by endurance only. My table's going to last a while here, but that's because it's durable. We're not doing that. We actually have to fight against the second law. We have to fight the tendency for us to fall apart, and it's really hard for us. We're not durable at all. I mean, you watch what happens to us when we die. We're gone in no time. We're actually pretty soft jelly-like stuff. So how the hell could something jelly-like have lasted 4 billion years? Obviously, it's not the same self, but it's a lineage of selves, and all of them, all along the way, have to be defying the second law, or basically regenerating itself fast enough to outpace the tendency to degenerate. So the question becomes, the question we're trying to corner ourselves with, how could existence by self-regeneration emerge by accident in such a universe? So I'm going to argue that there's two kinds of existence: the things that exist because they haven't broken down or fallen apart or petered out yet. That is existence by endurance. And then I'm going to say that there's existence by self-regeneration, stuff that's actually hustling to keep regenerating itself faster than it would otherwise degenerate. That clear? So here's a way to think about it. The question we're asking is like tightrope walking between two answers that we fall towards. One is the one I got from Vivian Ming, which is that there's no one home, we're just a machine, we're just mechanics, more to the point. And the other is that there's a ghost, someone home, by means of supernaturalism, for example, that God put in our bodies a soul or spirit, by panpsychism, which is that everything in the universe, atoms, quarks, all of those things have wants, so there's nothing to explain, or by the equivocation I'm just talking about here, right? So we have to avoid falling off in either direction. Say, no, it can't be that there's no one home. It's obvious that there's someone home. And we don't get to use any of these tricks. I can't just talk out both sides of my mouth and claim I'm doing science. I can't claim panpsychism. I know many people who do. It's a prevalent theory around this, panpsychism. Why can't I say panpsychism? Because if everything has wants, why do we end up with this radical difference between organisms and non-organisms? You still got to explain that. Even if you say that everything matters, that things matter to everything, you still have to explain why we're so different from everybody else. Now, yesterday I had a conversation with a Berkeley scientist who said it happens when you get enough cause and effect mechanisms all working against each other, all these pushes and pulls working against each other. Suddenly, when you cross the threshold, someone's home. I called this eventual massivism. I was trying to kind of find a ridiculing name for it. Like eventually, if you get a big enough mass of cause and effect stuff, suddenly it becomes alive.
There are actually brain theories like this, or theories of consciousness like that, aren't they?
Totally. It's the you could even say it's the prevalent theory.
Like there's a certain cap of like some kind of informational self-integration. So how much information there is, or how fast the information is being processed in the brain, and suddenly, boom! Oh, there's consciousness. Oh, it's a mind. Oh, it's a self.
Right. So there's an approach called integrated information theory, which is basically saying when you get a whole bunch of Shannonian information linked up, out pops the mind. And we're saying, wait a second, if that were true, a brain is complex. A brain has a whole lot of mass of causal connections, and it's conscious, but a galaxy actually has more. And a galaxy isn't alive. A galaxy isn't trying. So you still, like I say, if you're going to go with one of those approaches, which I changed the name to thresholdism. It's the idea that if you cross a threshold, suddenly you're alive. If you're going to go with thresholdism, you still have to explain why a galaxy has no consciousness, but a worm does. Not consciousness. While a galaxy isn't trying to do anything, a worm is. While a supercomputer is really complicated and you could say intelligent, it's not alive and a worm is. What the fuck? You have to explain this somehow. That's the issue here. Okay. So let's see. Hold on. Let me see. I can do this. Okay. We talked about this one already. Not replication, but self-regeneration. So I said earlier, not replication, but self-reproduction. Self-reproduction, by our account, isn't even the primary goal. It's kind of a side effect of other things. Molecules replicate passively. So I'm going back to that point I made earlier. They're replicating passively under certain environmental conditions. Yeah, you can have copying molecules by catalysis, but the molecules are doing no work on their own behalf to copy. They just happen to copy in certain environments. Self-regeneration is different selves trying to regenerate faster than they would otherwise degenerate. I'm going to list here, because I'm still trying to corner ourselves with the right question, 3 things we see life do that we don't see non-living things do. One thing they have to do is, like I said before, they have to repair or regenerate whatever degenerates. Stuff is degenerating all the time. Another is they have to protect themselves from the elements that would degenerate themselves. And if you can't really have self-reproduction unless you got these first 2 things. And I'm cornering myself by saying, yeah, it's really a self doing it. The self is doing the repair. The burden is on me to explain what a self is. Okay, so what's doing the trying? What's doing the self-repairing, the self-protection, the self-reproduction? Before I get to the question, what's doing it? I want to reiterate this point. We're talking about work done by a self. It's work by a self for itself about its circumstances. By itself means work that's trying and effort. Both of those are kinds of work, but they're different from everyday work. I did a video, I don't know if you guys saw it, it was about 3 minutes long, and it was about what I've noticed in my own generation. I was a hippie and I lived on a commune just like Maximus. In fact, I knew Maximus's uncle because he was on the same commune I was on. And this commune was full of the kind of language we had in the counterculture, which was a fascinating thing because it was so juicy, it was so full of life, and yet it was the driest chemistry talk, physics chemistry of all. So life is energy, we thought. It's good energy, whatever that is. You get this from people who say it all starts with a higher power. Well, yeah, it doesn't sound like a self, but they're not talking about a voltage here. So good chemistry, good vibes, vibrations are physical too, good energy, a higher power, all of that is physics talk. And yet we were using it as if it was the juiciest thing around. And this, by the way, is something that I think you have to watch out for in the writing of people like Dan Dennett. He writes a very spirited argument for why there's no such thing as spirit. He writes a agentful argument why there's no such thing as agents. He's like Vivian Ming this way, gives a really juicy human story and wants you to believe that there's no such thing as human, no such thing as life, in fact, because He's basically making a rich and colorful argument for the colorlessness of physics and chemistry. So you got the by itself trying an effort, you got for itself function and value, about its circumstances is the fittedness, interpretation, representation, or accord, the way that a organism, if it's going to stick around, has to accord with its environment, has to be in agreement with it. Terry and I looked up the etymology of the term interpretation yesterday. It means basically between trafficking at its origins. Obviously it means something else, but it's basically the self mediating the relationship, its self-other relationship. It's not the environment that is keeping it going. About energy, just to come back to that one as an example, energy doesn't give a shit what it does. And it's way more likely to blow things up, make them fall apart, than put them together. Energy doesn't care what it does. The gasoline, a gallon of gasoline you put in your, is just as happy to drive you to see your loved ones as it is to burn down your loved one's house. It has no preference, and it's more likely to burn down your loved one's house. So what do we mean when we're talking about energy being the source of it? That doesn't quite work. Energy is mostly degenerative, not regenerative. We have to explain how you'd ever get the kind of regenerative use of energy that you get in living beings. So selves are the business end of evolution. Maximus, how are we doing on time?
So we have until 2. So I guess we can keep going with the PowerPoint. Although, I think you were right when we were speaking about this earlier, that a lot of these ideas, they kind of need to come out through conversation. So I would love to pivot sometime soon to just sort of chatting amongst ourselves. I really like you folks to try to put some of these ideas into your own words, because I think that's the best way to really understand them.
Beautiful, beautiful. I'm all for that. I think I can knock these out pretty quick. The ones that are left, there's like 5 slides left. So if you go down a process of elimination and look at all of these things as if they are the explanation for what's doing the trying, I would argue, and we could get back to these if you want in conversation, but I'll just say none of these quite work. I've listed why energy doesn't explain it. Matter is kind of clear. All the matter is still there when you're dead. The moment after death, you haven't lost any matter. So apparently your selfhood isn't the matter. We've talked about evolution. We've talked about RNA and DNA. If they're trying, it's not obvious they're molecules, right? So they by themselves aren't trying to do anything. And a magical added substance, something we don't go there because that's supernatural talk. Okay, so that's why the book's called Neither Ghost Nor Machine. So what is it? So I'm going to go out to you to explain. I'm going to just touch briefly on Terry's theory. There's a whole lot more of it to be explained. That's why I wrote a book on it. And my book, by the way, is a distillation of his book. Our biggest personality difference is that he's an extremely careful scientific writer, and he fears deeply dumbing things down. And for 21 years together, this was a struggle between us because I wanted to make it as simple and accessible as possible. He wrote a 750-page book that academics found hard going. I read it 15 times or something and distilled that down to 260 pages. I can get it down, I think, to 100 pages in my next version of it. In the meantime, I'm trying to distill it down into videos. But here I'm going to just go to you. The question is neither ghost nor machine. So what is it? Let's talk about you. What do you do? What are you not doing to be doing what you're doing? You're in this class right now. You could have been doing 1,000 other things. So if it's not a ghost, it's not a machine, what else could it be? Or not the mechanism, what else could it be? I'm going to say it's self-constraint, it's focus, it's control, it's dithering prevention. Matter and energy can do all sorts of things, and it will when you die. The matter and energy that's in you will be freed up. It can do all sorts of stuff, but while it's in you, it's not doing all sorts of stuff. It's doing some specific stuff. And to make it as personal as possible, most fundamentally, you're focusing on maintaining your ability to focus. You're doing a version of self-repair, which is you're taking care of your health, fixing what breaks down. You're doing self-protection. You're keeping a roof over your head to protect yourself from the elements. And you're doing self-reproduction, maybe leaving a legacy, kids or brain kids. But let's just talk about kids here. That is, maybe some of you will go on to have kids. I've got a grandkid by now. Okay, so what is a self? I'm going to argue that a self is self-constraint. I know that sounds circular, but what I mean by that is it's a constraint that channels energy into work, what I'll call effort, to regenerate self-constraint. It's basically, it's the prevention of all the things that would keep you, that would make you fall apart. The self is the constraint, and it's the prevention of dithering. Life from its origins is degeneration prevention. So let's talk a minute about constraint. Well, I'm almost done here. We usually think of constraint in terms of imposed constraint. So water could spill everywhere, but a riverbank kind of holds it in. A riverbank is a kind of solid, enduring thing that prevents it from going everywhere. It changes the likelihood of where that water will go. How? By reducing some possibilities, it results in increased likelihood of other possibilities. It's as simple as this. The less variety you have, the more similarity. If you eliminate a bunch of possible behavior, of possible phenomena, you end up with focused phenomena, like you get in a river. But our bodies aren't held together that way. We don't have imposed constraints. I mean, we have some, and some of them are internalized. Like my blood flows through my veins, kind of like a river flowing through a riverbank, but that's not the kind we're looking for. I'm going to talk about something called emergent constraint. Emergent constraint is a molecular equivalent to what happens when you thread your way through a crowd, and in the process, you alter how others thread. So here's a little bit of that. It's not perfect, but you can see that pathways can start to form, like right in here. You can see that people are moving in columns, because the threading kind of self-simplifies into these, because everybody's threading around each other, okay? So that's an intuition pump on the idea of emergent constraint. And emergent constraint has been kind of a hot topic because of what I will call emergent regularization. That's a basic kind of emergent constraint. It's also called self-organization. What you get is a constraint propagation. That's what we just saw in that last video. And it's what we see in whirlpools and crystal formation and the formation of Bernard cells and in chemical chain reactions. I could go into the details and discussion on how that's emergent regularization. But basically all you get out of it is a temporary regularization. Take a whirlpool at the drain in your bathtub. It's temporary. Why? Because it makes the flow faster and therefore actually drains the water in the bathtub faster. So you call it intrinsically undermining. It undermines itself. It's not trying to do anything. It's also just a product of circumstances, but so it's not alive. A whirlpool's not alive. That's the takeaway. Emergent constraint number 2 is of interest to us. This is emergent constraint where you get the coupling of 2 emergent regularization processes that ends up yielding you those 3 features I described a moment ago: self-repair, self-protection, and self-regeneration. Immanuel Kant was the first to notice the possibility for this by saying that the difference between, let's say, a machine and a living being is that with a machine, with a living being, every part is means and ends to every other part. But then he says, but maybe that's just in the eye of the beholder. Well, Deacon's approach to the origins of life, the origins of purpose, is this reciprocal means to prevent ending. So when you get 2 of these processes that would otherwise end, processes like whirlpools, that basically prevent each other from ending, they add an additional constraint, this emergent constraint that you can call a meta-emergent constraint. It's the one that yields you self-regeneration. We can get into the details in discussion if you want. And here's my last slide. Imagine what it would be like to have an explanation for mattering as easy as our explanation for lightning. Imagine if every 10-year-old nerd had an explanation for how you get mattering from matter. That is, what would happen if we ever closed this gap? Maybe Deacon's model does it, maybe someone else's model does it, but we've been living for millennia without an explanation for this, and therefore having to dance around this hole in our understanding. I think it's an interesting question. What would happen if we had an explanation for what mattering is, what value, interpretation, selves, all this stuff, the kind of information we really use where there's good and better and worse information for us, all of that, what a difference it would make. So that's my slideshow.
I guess.
Great.
Oh, sorry.
No, go ahead, Victoria.
Just on that last point, I mean, I think that mattering is different to everybody, and I think that I think that's part of, life as a human is trying to figure out, why am I here? What is my purpose? And I think that if you were to, if science were to simplify that into one neatly boxed meaning for everyone, I think that, I mean, I don't know what would happen, but I just think that everyone goes about pursuing different things because of what they value in particular. And I think that it's important that it's a little bit different for each person. I mean, I don't know if I'm oversimplifying what you were trying to put out there.
You're spot on. And this has come up for me this last week. When Darwin put out Origins of Life, it was jumped on right away by 3 factions and then later a 4th faction that all said, yeah, survival of the fittest, that's us. So you had immediately afterward, they said, you want, yeah, survival of the fittest, survival of the what's most valuable, that's us. So you had the social Darwinists who are back in full force these days. That's what Bannon and Trump and the Koch brothers are really. They're also saying, you want the fittest, that's the rich ones. We should eliminate democracy because democracy is better handled by capitalism. With a bigger voice for whoever's doing better. The last thing we want to do is help out anybody who's at a disadvantage. That's like slowing down evolution. Well, that was an idea that was born out of Darwin. Darwin said, fuck no, that's just not how it works. I'm not saying anything like that. I'm talking about value whatever values. I'm not explaining the right values. I am explaining how value happes. And even in that, yeah, go ahead.
Darwin kind of had it coming because natural selection theory was totally like a rip-off of capitalist free market theory. I mean, he just borrowed economic models over for explaining.
Yeah, he had it coming, but then you have to ask about the other ones. Okay, so the other ones who said it were the communists who said, yeah, the fittest are the working class. And then you had the nationalists like the Nazis who said, yeah, the fittest are the Aryans. And then later on, you got the New Age version of it, which is the fittest are the sweetest. The meek shall inherit the earth. I have a friend who's who considers herself an avid Darwinist because it means that her New Age ideas are going to take over the world. It's inevitable. I dealt with a version of this last week. It was kind of fascinating. I ended up with a bunch of people, some of them humanists, and some of them libertarians, who said to me, oh, love your book. I think it proves that we were right all along, which is fascinating to me because I have a whole other career as a psychoproctologist. And this speaks very much to your point, Victoria. The main takeaway I get from evolutionary theory is that life is negotiated through cooperation and competition among different values. And you'll get that from many an honest evolutionist. My argument is, yeah, that's cool, but it's just another dogma in the fight if it isn't grounded in physics. It's just another thing you're positing because we still haven't grounded evolutionary theory. Once we do, yes, it's a negotiation among values. That means I actually believe that one thing you can take away from this theory, one thing you get if we find that explanation for mattering, is exactly Victoria's point, which is we are going to be negotiating this. So my interest as a psychoproctologist is that in a free society, you don't want to tell people what to do. You cannot, nature doesn't tell you what to do, but you still have to put a leash on assholes. And so, I mean, I've done a bunch of videos on exactly this question. It's been with me for 21 years. What is a butthead other than someone I butt heads with? It ain't enough for me to disagree with them for me to say this guy's out of line. And yet that's how most people play butthead police, is they go around saying, look, if you disagree with me vehemently, you're a butthead. Yeah, that's not good enough for me. And what we end up with is a whole lot of butthead on butthead combat. And so that's one of my interests, is that how would you constrain it? And I think I came up with an answer yesterday, and I put it online last night. I realized that, so I'm dealing with these guys who want to read that nature nature defends their personal values. And I'm saying, no, nature doesn't tell you how to live. It'll tell you what will die. You know, in a way, it's like a flat earth version of things. You can roam anywhere you want on the whole value sphere. There are these places, though, where you can fall off. And if you do, you're gone. And that's okay, too, if you decide to sacrifice yourself for love or country. Nature isn't even telling you that it's better to live than die until you get into life that basically is trying to. But it gets really squirrely with humans. So what I decided to do was...
I think to speak to your point directly, Victoria, is that the idea here is that we don't necessarily want like scientific rules for telling us what's important. We want scientific rules for telling us how importance exists.
That's
right?
exactly right.
Currently, science tells us that importance is this epiphenomenal thing. It's a thing that like you imagine, right? But physics doesn't have any importance to it.
Right. That's right. So what I decided, if there's anything you could take out of, so we're saying, Terry and I came up with this week that we're not into moral relativism or moral absolutism, but emergent moralism. And so what I decided to do yesterday was to write a quick start user's guide for humans for the very challenging issue of adapting under the influence of language. It's really radical that we've got language. It makes a very big difference in in the kinds of possible values we can have. And so it makes for a much more rickety ride than evolution did before. So this is a guide. I just put it on Psychology Today yesterday, which starts with congratulations on your new acquisition. If you're reading this, it must mean you're up and running with this new power to read, write, talk, listen, and above all, think using this new power language. Here are some guides for thinking about how to do this. And basically, one of the things I say is, you're still going to need to pay attention to reality, what'll kill you, or what'll kill whatever you care about. You have to be realistic, but you also have this power to fantasize. So it's basically on this issue of how to distinguish between fantasy and reality so that you can engage in what I'll call optimal illusion, which is to kid yourself where it helps, but not where it doesn't. And this is a big these days.
I'd like to hear a little bit more from the rest of the class, because like the ideas here, on some level they're very simple, but on the other level they're just like they're really hard to grasp. And so I would love to maybe do a go around even, and see if you folks could try to maybe summarize the core argument that we've been trying to get at here, and then maybe we can pull out some ambiguities.
And actually, the core question might be good.
Yeah, the core question. That's a better way to put it. Yeah, I mean, because I think a lot of this is it's about framing a question. There's this question that we haven't been asking properly, and all of this talk, right, is what we're trying to do is frame this question better. And I want to make sure that we're doing it. So maybe we can start with Nwang. I do want to hear from everybody, but like, so what is the question that you think we're trying to get at, and do you have any satisfaction with the way that it's been painted?
Honestly, there have been so many different topics that we've brought up that I'm not like one set question. It's just like I can't think of it, but like I think the main takeaway that I'm getting is that the cyclic nature of like self and self like awareness, like honest. So I like wrote down a question here from one of the parts. Like we talk about self, and we talk about self as like humans, but do you have like an idea of what self, if there's a self in other organisms? Because we talk about language and we talk about self regeneration and preservation, which other organisms have, but and they have like organisms have their own constraints as well. So do all the qualities that we've talked about, like would they relate to other organisms? Like, I'm not understanding how.
Great question. Great question.
Jeremy, before you answer it though, I'm wondering, could one of the students answer it?
I agree. That's exactly right. I mean, that someone else should answer it.
I think that other organisms do, but I don't really know where you would draw the line. Like, I think that that's the hard part, is like you were saying, like a worm, like it has wants and it's different from, I forget the example that you used. But
Yeah.
what, you know, like how do you know what a worm wants? It's just like, does a worm have a self, and how do you know that?
Great. Anybody else on this one?
Richard?
I'm not hearing Richard.
Your microphone is muted, Richard. Here, I'll unmute it. There you go.
Yeah. Well, it's kind of hard to conceptualize it, but basically I don't know how to put it, but it's really hard to grasp at this point in time. Maybe I need some time to think about it.
Well, I guess so. Let's return back to the question that Victoria raised, right? Like, so if a worm has a self, how would you know what it wants, or how would you know that a worm has a self?
Wait, but to the qualities of a self, I don't know if a worm would have that. Like, they don't have a language. They just have, their only purpose to themselves is to survive and reproduce. So I don't know if that constitutes as what self is in like the definition that we've been talking about.
Yes.
Like, they don't have a personality.
Yeah. I think language certainly, at least in my view, language certainly fundamentally alters the way we're able to reflect back ourselves to ourselves, and reflect back our goals to ourselves, and reflect back the worlds around us to ourselves. But I think this is a maybe the most important question is what constitutes the two big questions for me are what constitute the first self,
Yes,
and what constitute these major leaps in what is a self, and what is a goal, and what is an experience. Because certainly my experience is not the same experience as a worm experience, nor is it, I mean, there's a real difference in kind there, not just a difference in degree.
Yes, let me jump in to say something, just because I want to make sure we have time for all the questions that would follow from this. I mentioned earlier that to me a tree is a self and a bacterium is a self. That itself is a big leap, and maybe I shouldn't have even wasted time with it. I could have just called them organisms. But what I'm talking about is basically the difference between things that are trying to do things and things that aren't trying. And where do you draw the line? Yes, as Mel says, there are many lines. Remember that Terry did this major work on the difference between organisms that have language and organisms that don't. He's very big on those big differences, but we shouldn't be confused. The bigger question is, where do you draw the line between things that are trying and things that aren't? And that's a live debate. But I want to argue the simple solution, which is everything that we call alive is trying. What does it want? Well, it wants to keep going. We see that, we know it by the fruits of its labor. It's not necessarily going to be fighting back in Mortal Kombat. A tree doesn't actually have a way to push back if you push it against it. It's not going to actually kick you away if you try to cut it down, and yet it is nonetheless trying to live. The will to live is basically the definition. So back to Victoria's point, I'm going to argue that at the origins of life, we have to find real value. We have to find real interpretation, but these terms are going to be defined more broadly but not vaguely. We have to be very careful to distinguish between what is doing something because it values it and what doesn't. And no, we're not talking about consciousness or self-awareness or or feeling or emotion. None of that stuff. That shows up way later. Terry says to try to explain selves starting with humans is like trying to explain hair starting with porcupine quills. Yeah, they're hair, but they're weird here. They're not representative of the whole, and they're very evolved. They're a peculiar example. So this is where he says, consciousness studies, man, you guys got to walk before you run. If you don't even understand what the will to live is, how can you try to get at free will? How can you try to get at will in consciousness? So that would be the broad answer.
So I want to, Naveen, I want to go back to you for a moment, and I'll ask you, I guess, what do you think a self is? I think that maybe that's the question that I want to ask everybody. So what do you think a self is, given what we've heard?
I feel like to have self is like to have choice, kind of. Or to like,
so like choosing your own way, kind of a thing.
Yeah.
And is a choice, would you limit that kind of choosing to the kind that we humans do, where we weigh different options, like you're deciding where to go for grad school or something like that?
I feel like it could be more general.
Yes. So just to draw a link between what you're talking about, what we're talking about, yeah, it is more general in our opinion. And it shows up first in this ability to prevent possibilities. It's not conscious. It's not like a bacterium is saying, hey, should I live or die today? But embodied in their body is the choice to prevent certain possible behaviors in the interest of following other behaviors. This business about not dithering. And with death, you dither. You do whatever. So that's one way that, in our perspective, that choice shows up. It has to be there from the beginning of life. This prevention of some possibilities so as to achieve other possibilities.
So I have another question for everybody, which is are these kind of questions, is it something that you have thought about before? Like maybe not in this framework, but like in what ways have you pondered this in your own lives, I guess, is the question I want to get at.
I've definitely like thought about values and aims and goals, because more so in the sense of humans, just because I think that gives us a sense of purpose and kind of is what makes us keep going. But I haven't really thought about like what I guess is directing those values. Like I've never thought about what a self is, or a spirit, or a soul. I feel like I've always acknowledged its presence, but never really tried to formulate what exactly created it, or why it's there, or what its purpose is. But I feel like that is kind of something that's important, because it seems kind of weird to acknowledge that something is there, but not really question why it's there.
Or how it's there.
Yeah.
Yeah, I mentioned this early in the book. We are self-obsessed. We are paying lots of attention to our purposes, but we very rarely ask the question, what is a self? What is a purpose?
I haven't really given much thought to this, the idea of a self, only because like in the psychology courses I've taken, they usually explain, they like would equate self to a personality, and that would be all like cerebral, like like an evolution of the brain would lead to like the amygdala and like the frontal lobe leading to personalities and differences between more evolved organisms versus less evolved organisms, and then also how, and then I also would thought, well, I guess now I'm thinking about it, but a self being influenced by like anthropological qualities like culture and society, rather than like self just a self just coming out and like being there. Like for me, it's all an evolution of a person. Like that's how I've been thinking of it.
That makes sense.
Richard, have you chewed on these ideas before?
No, not really. But I mean, I'm thinking, well, maybe more dependence on human evolution, on like how we can evolve to survive. Like thinking of it in a general form, but not personally thinking about like self from a purpose, but having categorizing like the whole human race, being able to adapt, years over and over, but not really thinking like what will happen, what the end will be, or something like that. Just
Yeah.
there.
Now I have a question.
Yeah.
If we didn't have the self regenerative and self reproducing qualities and like desires, would we then not have selves? Like would the self not exist if we didn't have the desire to reproduce and survive?
Well, what's your guess on an answer? Like first pass guess at that.
I would.
Would the self disappear if we weren't busy trying to survive and reproduce? That's your question.
Yeah, that's basically my question. Like I don't really get how. I mean, I understand how wanting to not die off is important to self, but I think that's like, isn't that more like the self as a whole unit rather than an individual?
Well, the whole unit as compared to, you mean as compared to parts of it?
An individual rather than like a population. Like reproduction is just to continue a species population. So why would that have to, unless it's like your selfish reasons to continue your own bloodline? Is that what it is?
Well, it's first of all, it's often it's mostly not conscious, right? I mean, there's all sorts of organisms that are not deciding that they want to reproduce. That's something that we do more than others, and it's interesting, especially in this generation, to think about how we do it. We do it kind of automatically. That's all that hormonal stuff about sex and all that. But we also often make the choice, and these days I have more and more friends who are deciding not to have offspring. I would argue that some of that's because the brainchild evolution has gotten so interesting and exciting that a lot of us want to spend our lives reproducing ideas more than reproducing babies. I have 3 kids and 1 grandkid. My own feelings about it are ambivalent. In some ways, I pay more attention to the generation of my ideas, and it's kind of a relief for my kids because they can go off and be themselves without me busy trying to make sure that they do something that's reproductively beneficial for me. But in a way, that's all a kind of a sidetrack here. The main question is, look, a minute ago, I just produced a new skin cell. And in a minute, that the old one is going to be gone. I'm busy doing that stuff right now. I'm not very conscious at all of all the self-repair I'm doing. If I were, I'd be very confused because you guys know a whole lot more biology than I do. But nonetheless, that's me doing self-repair all the time. So if I stop doing that, would a self exist? Is kind of, I think it's in the same family as Victoria's question. My answer to it will be yes. Because if I'm not self-repairing in this universe where everything falls apart, I'm a goner really quick. That's kind of my definition of death. Death is when you stop doing all the self-repair, all the stuff that happens as a product of the ways in which all of the systems in my body are checks and balances on each other, constraining what happens. If that stopped, then everything's free to do whatever, and I'm dead. I didn't mean to bum anybody out. Look, I'm sadder about it than you guys.
Well, so I wanna return back to the final question. Ooh, there's someone needs to mute. Okay, there we go. I want to return back to the final question in your PowerPoint, which was, what would the world look like? Would it look any different at all? Or how would it change your life or the way you see things if there were a physical, a scientific account of how mattering emerges out of matter? Like how, and this is a question to the students, is like how, if you knew you could pick up a book where that explanation was there, would it change anything for you about the way that you see yourself in the world? Or maybe it's just like a curiosity question, but doesn't really have much relevance.
I didn't understand that question. Sorry.
I guess I'm wondering, like,
let me frame it up. Suppose that any 10-year-old nerd could tell you in about 5 minutes how mattering emerged from matter. That we were at the point where our understanding of how mattering emerged from matter, how selves and trying and all that was different and how it even started. If they could explain all that as easy as they could explain lightning now, would that change anything?
I don't know. Like, I don't know that it would change anything, just because I guess it'd be a mystery solved. But I mean, like all of science, like we think we figure things out only to keep learning more. So we might have like a basic concept of how mattering evolved, but I think that there would still be people out there trying to figure out more about it. So I don't know that, I guess, the journey to figure it all out would end necessarily.
Yeah, so you're saying it wouldn't end science, for one thing.
Well, yeah, no, because I think that science is just something that is constantly, I don't know, I personally feel that I am always learning something. And I just think that there's always something else out there to explore and learn about. So even if a concept about matter could develop, I don't think that the conversation would end.
Me neither. Others?
I think if someone gave me a book that answered every question I've ever had, or like gave us a book that answered every question, I think it wouldn't stop discussions in any way. I think it would just evolve. It would lead to an evolution of the discussion or research being done. Like, people just always want to know more, so they'd always try to build their knowledge on whatever that like book of everything is saying.
Yes. Interesting that we've gotten off on this, because we're certainly not saying that this explains everything. What we're saying is that we need a bridge between the cause and effect world and the means to ends world. One thing I've loved about working with Terry and the rest, which includes Maximus for 21 years, I mean, Maximus not that long, but is that we're always dealing with the next question. All sorts of questions follow from the idea that you might ever have a physical or natural explanation for what these wants and drives really are. So we don't stop wondering, and I like that about it. maybe another way to frame the question, is there anything that we currently think that would be less powerful if we actually could explain scientifically how mattering emerged from matter? Is there anything that would be weakened by that? Could we drop anything, for better or for worse, if we had an explanation for it?
Well, I think that there's environmentalist interpretations to much of this stuff, right? That like when you choose to identify life in this reciprocal way of like life is processes that perpetuate itself, and you look at the various global ecological catastrophes that we're causing, you say, oh, okay, like here's a very simple explanation. But people already have that explanation. You can say that like deforestation is bad without having to point to teleodynamic theory. But
Which is what this is.
I actually think the opposite. Can you hear me?
No, Mel, go on.
Oh, can you hear me now?
Yes.
Yes. I actually think quite the opposite. I think that for me, there's everywhere in any field I touch. Mostly I'm in contact with philosophy, cognitive science, and evolutionary theory. But I see implicit norms everywhere, and I don't like it. I don't like how it points value in a direction and tries to say that there's some kind of objective metric by which something can be said to be successful or something can be said to be right. And so for me, what this would do would be to put in a scientific basis for subjectivity.
Mm.
Rather than, you're saying a scientific basis for the variation in subjectivity that you get? Is that what you kind of mean by it? Like that the thing you were saying earlier, which is that there's a diversity of values, and if we don't honor that because we claim that there's one true natural value, is that what you're kind of getting at?
Yeah.
So because our time is short, I want to drop mine in here and then get the remaining answers. I'm really interested in what this does to the science-religion debate. I admire science a lot. I don't admire religion as much. I understand it. I love to study it. I've taught theology once or twice. But one thing I notice about it is it allows people to use what I'll call wildcard trump cards. If you can summon up a supernatural source of values and say it's super, which means it's bigger, trumps anything else, we end up with a kind of dangerous world. What do I mean by a wild card? If it's supernatural, science can never get at it. It's non-falsifiable. Apparently, lots of different people believe lots of different things about what the supernatural commands us to do. God's values are different for different people, or the higher power's values are different for different people. That makes it a wild card. That's not testable. There's no way for us to ever resolve those disagreements except by force, by power, by some kind of, could say postmodern debate where it's just whatever's the most powerful version of God wins. That's the wild card part, and I don't like it. And the trump card is, my wild card is the values that we all have to live by. So while I don't admire religion as much, I do admire religion more than science for actually feeling like they have to have an answer to where purpose comes from. But scientists often act like, no, you don't have to explain purpose. Evolution explains it, or we're just machines, something like that. At least the religious people know that we have to have an explanation for purpose. Now, I find their explanations entertaining. I've invented 3 religions myself. I'm an atheist, but I think they're fun to invent. But the point of having finally an explanation of this is it does weaken the ability of people to say this is what a higher power wants from us. And I think that would be an interesting thing. Would it actually happen? I've asked every theologian and many scientists too this question: if we had an explanation, would religion fade away? One notable I asked was the guy who won a Nobel Prize for inventing the laser. He and I sat together at dinner, and he said, no, it wouldn't. I kind of agree. It's quite possible that you could have a complete explanation for how mattering emerges from matter and still want to believe in God. I mean, there's all sorts of people who fly in airplanes because they're scientifically grounded, but still believe in God. So it's easy enough for humans to have a firewall. Still, I think it's nice for science to have a real argument about where purpose comes from if it's not going to come from some wild card trump card. It's an interesting range. And by the way, I have to say, nothing about a physical explanation for mattering really eliminates the possibility of God. There could certainly be a God, and there'd still be the emergence of mattering from matter.
My problem with both science and religion is that they tend to hand down normativity from the top, so it's top-down value. Whereas the point for me is no, value bubbles up. Value is emergent. Value comes from something much more simplistic and fundamental. That's my take.
Yes, and to be clear, let me ask you a follow-up question on that. So this is a campaign to try to figure out how value or mattering or norms bubble up. Are you saying that you have trouble with science these days because it doesn't explain it, and you have trouble with religion because it explains it top down? You're saying that science is actually these days telling us what the proper values are, that we should all live by these?
To some extent, yeah. I think
scientific institutions, certainly, right? Like maybe the abstract intellectual process of science is neutral on it, but the institutions are not.
Yeah, I think capital T truth is getting pushed around and has a lot of agenda because it's money, right? It's capital, right?
Well, there's that certainly too. Yes. So to be clear, there's a way in which what we're saying resonates with postmodernism. When we're saying, look, it's negotiated, and yeah, power makes a big difference. The difference is that we do think that there's a capital T truth, which is that there are certain things you can do that'll kill you. There are certain things you can do that'll end life here. Now, does the universe care whether we end life here? No, I don't think so. Do we? Yeah, there's a general consensus that the meaning of life is not to end it. But the details of our competing values are huge. So it's different from postmodernism, is that we think that, look, you can believe anything you want, but some of it will kill you. And that's the extent of the values that we're arguing might result from this. Apparently living things try to keep going. They apparently want that. That doesn't resolve who gets to keep living. That happens through the negotiation between us all. But it also, in a way, capital T truth gets the last word. I can believe whatever I want, but in debate with reality, reality ends up deciding whether I get to keep living or not. And that's an anthropomorphizing I just use poetically. No, nature isn't trying to do anything. It's, that is, physics and chemistry aren't trying to keep me alive or kill me off if I make bad choices, none of that. And yet there's a way in which it trumps all other arguments. We still got to deal with whatever is reality, not that we know what it is. We're only guessing at it.
So we should probably bring things to a close. I'd love to hear some final comments or thoughts. I guess I'm particularly interested in your folks' thoughts because I think there's this just has potential of intersecting with the way that you think about your actual life, but also has the potential of just sort of seeming like academic gobbledygook. And I wanna make sure that it lands more on the former than the latter. So do you folks have any final thoughts or comments before we conclude?
Max, white people grad student garbage.
yeah. That I want to avoid it, even as I am. Yeah.
I guess the last bit about religion was kind of interesting, just because I feel like religion seeks to I guess, explain everything, and science does the same. And while religion has kind of discussed, I guess, purpose and value and meaning, science hasn't, and I never really thought about that point. So just having that point was it that stood out to me.
Great.
I kind of think slightly opposite about religion. For the most part, I think religion gives a very baseline purpose on anything. It kind of just says, like with religions that have a God, capital G God, they just attribute things to him, capital G. While like some other religions might try to say the purpose of life is just to live, which is my issue with science as well. Like, I don't think science or religion really explains anything right now. They kind of just say like what it is and have people try to just accept it for that.
Cool. Well, thank you all. I had a really great time. I hope you all did too. So we're just approaching 2 o'clock, which is our end time. So unless there are final burning comments, I think we can end it here. Thank you so much, Jeremy, for your time and your very interesting lecture. And I'll be sure to send you the videos that the class makes about their thoughts on these topics.
Great, and thank you all for thinking with me. It's very fun, very fun.
Thank you.
All right.
So the way I typically do this is I'm gonna end the broadcast now.